back to the Dr. Balmer channel. As of now, we are pretty much in the middle of a series on overclocking the Asus GTX 950. And let's take a break from that, I think, because today I want to have a look at a battery charger. This is the XTAR VC4 charger. It has got 4 bays, and what you might immediately notice is that it doesn't seem to support charging of 9-volt cells. And that is correct. However, it does support the following battery types. So the input, first of all, is 5 volts and 2.1 amps. It's supplied via this DC input, and with the charger there is a USB lead supplied. I don't have it here because this charger I bought a couple of years ago, and I don't have that lead anywhere to be found at the moment. So basically you can charge your batteries, your nickel metal hydrides or lithium cells from pretty much any USB enabled device that can put out a decent amount of current. So on the output side, it's 4.2 volts for the lithium cells. The current is divided. So at maximum you can charge 2 cells at 1 amp or 4 cells at half an amp. And yeah, this applies to the following sizes of lithium-ion batteries. We have the typical 18650s, 16340s, 14500s, so, and everything in between, up to a maximum of 32650s. Also for nickel metal hydrides, we have a quadruple A, triple A, double A, single A, and standard C and D batteries. Reverse polarity protection, and please use specified adapter. Well, this didn't come with any supplied adapter, so I went ahead and bought a universal adapter. I believe this was bought from Claes Olsson. It has a selectable voltage. It's set to 5 volts, and this can supply a maximum of 27 watts. For 5 volts, 2.25 amps. So this should be plenty for this charger. And if I connect it here, and connect this end to an outlet, then what do we get? Well, hang on a moment. I believe my connection isn't great. Now perhaps. So what do we get? Well, we have a display. It's showing the battery voltages. It's showing the charging current. And interestingly, it's showing half an amp, even though we don't really have any cells inserted at the moment. Also, we can see that it will measure the charging capacity of the cells. We only have one button, and this makes it very simple because you only have one button, so how much can you do with it? Well, you can push it for 1.5 seconds, it will turn off the backlight. Or if you press it again, it will turn on and stay on for about 2 minutes in this case. So this charger costs about $20, $22, $24 on AliExpress, I believe. And then it doesn't include a charging adapter brick. So if you want to charge from anything else than a USB port, from a USB charger that you already own, and you want to buy a USB charger for it, or like in my case, a brick, then a dedicated charging adapter, then you have to factor in the cost for that one as well. If we have a closer look at the charging base, we can see that it says max 1 amp on the first slot, half an amp on the 2 inner slots, and once again 1 amp on the outer slot. So if we populate 2 slots, 2 batteries, and want to charge for 1 amp, we have to put them in the outer slots, and at half an amp in the inner slots, and if we use all 4 slots at the same time, we have a maximum charging current of half an amp. So let's insert some batteries. And for instance, I have these Nightcore 16340s, or RCR123A and L166 they're called, from Nightcore, and they usually sit in this Arlo camera. So these are depleted according to the camera. So considering that these cells are at a max capacity of 650 milliamps or milliamp hours, we don't want to charge them at 1 amp. And this charger, now the display has gone a bit dim, so we can press it. You can't really choose the charging current in the steps or anything. So you either have half an amp or 1 amp. So it's very simple in that manner. So for charging cells, small cells like these, we should go for the inner slots. We can see that the indicator light for slot number 3, channel 3, is now red, indicating that is charging, we can see the voltage. The battery is 3.9 volts currently, and it's charging with half an amp, and the accumulated charge is now at 4 milliamp hours. Now, let's insert the second cell into channel 2, and now we see some action on the left side, and we see that something is going on here. So perhaps I had a bad contact between the negative or positive connector, because once I moved the battery a little bit, it now stabilized. So ultimately, the tension of these springs will also dictate how stable of a connection you will get. So for short batteries like these, you're almost, I mean, a spring will, the tension will become greater the further you extend it. So for batteries like these, yeah, you see, now I just nudged this battery and it lost contact. So I have to give it a little nudge, and even now I'm losing contact, it seems. These batteries are, however, pretty old, and this charger doesn't really tell us the internal resistance or anything like that. So in this case, I'm not really sure if the battery is bad, the connection is bad, or what's going on, which is a bit unfortunate. So yes, as I was saying, for short batteries like these, you only extend the spring about this much, so you don't have a whole lot of tension. And I believe this causes the very sensitive connection here, which is a shame, because it makes it a bit hard to control it. And also it says that I have already reached 4.2 volts, so either the batteries are pretty bad with high internal resistance, because they jumped up to 4.2 volts so fast, or something else is not great. So being this simple of a charger compared to the DLY full A4 battery charger, if you haven't seen the video that I posted previously on that one, have a look at that. That charger shows a whole lot more information, and that's really useful in many instances. For instance, in an instance like this. So okay, but let's remove it from here, and what if we insert it into a 1 amp slot? What will happen then? We see the current jumped up to 1 amp, but the battery is almost full, it says. Still, so okay. Right, so let's bring in some better batteries that I know the condition of. One moment. So here I have two pink 18650 cells, and these are I believe 2600 milliamp hours each, so we can safely charge these at a current of 1 amp. In this case, we would like to put them into the outer slots. So I have the negative here and the positive here, so we insert them like this. And now I can feel that there's a lot of tension here, because now we're extending the spring a lot. These batteries are about 83% full, according to my power bank that shows capacity. And it's probably about right, 4 volts. And we can see that the charging current has dropped from 1 amp to 0.9 amps. So perhaps it's automatically decreasing the charging current as the cell closes into being fully charged. So let me insert the second cell. Now the current jumped to 1 amp again, so we have 2 times 1 amp. And it's about equally charged. And yeah. So currently I'm charging 2 identical lithium-ion cells. But let's see what happens if I try to add 2 standard nickel metal hydride cells. So here I have 2 Amazon Basics, 1.2 volts, 2000 milliamp hours, rechargeable AA cells. So if I insert this one here, now we can see that we only have 2 dials here, 2 gauges, and it's showing channel 1 lithium ion, channel 3 nickel metal hydride. So it correctly identifies the chemistry and battery type, and we have also seen that we have dropped to half an amp of charge because we have populated more than the 2 outer slots, so we can supply 3 total amps. And if I press this button, then we can see that the channels here should change, one of them. Yeah, so the right one changed from channel 3 to channel 4. So now we're inspecting this rightmost lithium cell. And we can see that it has reached 40 milliamp hours of charge. If we press again, the right gauge changes back to channel 3 indication. And if we insert another battery into channel 2, it also turns red, and now we have channel 2 and channel 3 showing. So yeah, we can't really see all 4 battery voltages at the same time, or the battery charging current exactly for each slot individually. We only see that we are in half an amp mode right now. Yeah, we can see these nickel metal hydride cells are pretty depleted at 1 volt. So they need to be charged. If I press this one, now I see channel 1 and 4, so I bracketed lithium cells. And yeah, that's basically all there is to it. What else can be said about this charger? Well, this charger claims to be able to restore broken cells that have reached 0 volts. And also it will try to charge batteries from 0 volts for about 10 minutes. And if the battery doesn't accumulate any voltage, it will basically show null or error if there is a polarity, reverse polarity, or if the cell can't be charged properly, indicating that the cell should be recycled. Yeah. And also it claims to basically be able to charge from any 5-volt source, even solar panels. I haven't tried that because I don't have a solar panel currently, and a solar panel should be then large enough to be able to supply a decent amount of current, especially if you want to charge 4 cells like this. So a little side note then. So in this case we can see that channels 2 and 3 have finished charging the cells, indicated by the green lights. And if I switch by pressing the button here, we can see the capacity. It says full, and the capacity for each cell. However, channels 1 and 4 are still charging. But the charging current is at 0.5 amp, even though these two, when populated only, should be at 1 amp. So worthy of note then is that if I would like to get 1 amp now that these two are finished, I would have to remove them from the slots. So let's see what happens. So far still 0.5 amp. Oh, okay. It went to 1 amp, but as soon as it did, it realized that these two cells are also fully charged, because we have 2070 milliamp hours on them. And once we increase to 1 amp, I suspect we got a small voltage drop, and the delta V voltage detection in this device probably triggered, indicating that they are full, because they were very close to full. So these cells are rated for 2000 milliamp hours. Yeah, so they were pretty much full, but at 0.5 amp they didn't trigger the delta V, I suppose. And as soon as I removed the second battery here from the inner slots, then at 1 amp I suspect that the batteries got a voltage drop suddenly, and the device then triggered the fully charged state with the delta V detection. But just to demonstrate, if you rewind back to where I removed the second battery, you would see that the the charge current indicator jumped up to 1 amp briefly before these two remaining cells were indicated as fully charged. Yeah, so this is just a thing that's good to know, because if you want to, you won't automatically get the faster charging of the remaining cells just because these two, for instance, have finished and no longer are accepting a charge. You have to actually physically remove them to get the 1 amp per channel for the remaining ones. However, I should also mention that that is not only a bad thing that the charger behaves this way. Why? Because let's say you have AAA cells, for instance. These ones are at 900 milliamp hours each. Or perhaps you have even lower capacity cells. Like the 16340s I had, the lithium ones, at 650 milliamp hours. In that case, just because the two inner batteries, for instance, are finished, and you have the capacity for 1 amp, perhaps you don't want to suddenly blast such cells with 1 amp of charge current. So in that regard, it is sort of a safety feature as well. So I don't think that it's a bad thing, actually. Just a good thing to keep in mind, that if you have high capacity cells, if these cells are finished, then you can remove them if you want the higher charge current on the remaining cells. Yeah, so what's the verdict with regard to this XTAR VC4 charger? Well, like I mentioned, I feel that the tension isn't too great on the shorter batteries because of the springs that need to be extended quite a bit to build up the tension, which would then press on the battery to make sure that the positive and negative terminals are properly touching the terminals on the charger itself. But having said that, I mean, this charger does have some features that usual cheap dummy chargers with very simplistic or no LCD display at all often lack. I mean, we still can see the accumulated charge, the battery voltage, and the charging current, at least overall. And as far as I can tell, it has been a fairly decent charger. You see if something's wrong, and it behaves strangely in that case. Oh, I should also mention, it claims at least that it will make sure that the batteries don't overheat. So it should have a thermal sensor somewhere, because it says that the surface temperature will not be allowed to exceed 15 degrees Celsius. Of an increase, that is, from ambient. And in that case, it will probably lower the charging current, I would suspect. And I haven't actually, I mean at 1 amp, unless you're charging a very small battery, a battery with small capacity at 1 amp, you shouldn't really trigger such a high battery temperature. And I usually don't stress my batteries by doing so. On the downside, we also have another thing, and that is that we can't really choose any charging current ourselves in between 0.5 amp and 1 amp, and we can't set the charge current individually for each cell, for each channel. And also, we don't really have any information on internal resistance. And that's a shame, because usually bad batteries that have some oxidation, I said, but perhaps crystallization or whatever happens inside around the terminals or something. Usually this will lead to high internal resistance, and you can quickly see that a cell is bad and that you can safely discard it. But in this case we don't really see that. So if this is your only charger, then perhaps I wouldn't recommend it as your only charger, unless you're perhaps today using just a simple charger without any display at all, just some indicator lights or something. Then of course this is still a whole lot better. But even then, for $24 or something like that, I believe you can get other chargers which perhaps have the same or higher quality, and perhaps they can charge 9-volt cells as well. This doesn't support the LiFePO4 chemistry lithium cells either. So it has quite a few drawbacks, and once you enumerate them, you realize that maybe there are better options. With that said, however, there's nothing inherently wrong with this charger, and especially if you want to connect it to solar panels, or charge slowly from a PC USB port, or you have a USB mobile phone charger and you don't have to bring any extra power adapter with you. You can use whatever capacity of your phone charger is, and just connect it to that charger. So you have pretty much universal input, but it's only 5 volts input, and also you're maxed out at 1 amp. So for large cells like 18650s or larger, which usually have even higher capacities, perhaps you're up to 4,000 or 5,000 milliamp hours. In that case, you will have to charge for quite a long time. And in that case, we would like to have the option, perhaps, to choose a charging current of, let's say, 2 amps. But in this case, we really can't. We're maxed out at 1 amp. But on the other hand, if this is not supposed to be your fast charger, and you want to be sort of kind to your batteries, then the choice between 0.5 amp slots in the middle or 1 amp slots on the outer channels is probably good enough for most use cases. So basically it's up to your needs. But I'm a bit disappointed that this charger is a bit too simplistic for its own good, because it loses quite a bit of points, so to speak, by being so simple. Of course, having only one button, I mean, it's easy to use inherently, but that is a compromise that also comes with some drawbacks as well. Yeah, so this is a quick look. Well, this video is almost 30 minutes already, so sorry about that. But on this channel we don't hurry too much. Yeah, this was the XTAR VC4 charger. Hope you have enjoyed this video, and check back for more, because there will be more. We should continue to explore the GPU overclocking. There will be more parts there because we're aiming at the top there in Firestrike, as well as TimeSpy, which we already have reached the top for. So definitely check back, and there might be some other interesting things as well in between. So I hope you have enjoyed it, and thank you for watching, and I see you in the next video. Bye bye.